So, hello everyone again. This is lecture 5 part 3 of current electricity. In the previous lecture we completed a discussion of cells, EMF, internal resistance with an example. Today we will start with a new discussion. So, let us not waste any time. I am Sameer Lavankar. Let us begin our discussion. So, right now in the previous lecture we completed the concept of cells, EMF and internal resistance. Today we will start with a new concept called as cells in series and parallel. So, cells in series and parallel. Just before this concept we understood another concept in which the resistors were in series and parallel. Today we will go on with another discussion now, that if the batteries are given to you in series and parallel, then what will be the equivalent EMF produced. So, just look over here, very easy mathematical formulation, nothing typical in it, you just need to understand everything. Okay. So, like resistors, cells can be combined together in electrical circuit, and like resistors one can, for calculating currents and voltages in a circuit, replace a combination of cells by an equivalent cell. So, first of all consider first two cells in series. So, let us suppose we are taking this case only. So, first two cells in series with where one terminal of the two cells is joined together. So, this terminal has been joined together, leaving the other terminal in either cell free, So, we are these two are free. Epsilon 1 and epsilon 2 are the EMFs for two cells, and R1 and R2 are the internal resistances. So, we can just assume this as equivalent to like this. Let VA, VB and VC be the potentials at points VA, B and C respectively in the above figure. So, here it is VA, here it is VB, here it is VC. Then VA minus VB is the potential difference between the positive and the negative terminals of the first cell, quite evident. Hence, VAB is nothing but VA minus VB, which is equal to epsilon 1 minus IR1. As I explained to you, we can understand this analogy like this, and because there will be a resistor which is present there, there will be a dissipation, and hence the potential difference will be nothing but epsilon 1 minus IR1. So, it has been explained here. Similarly, VBC is nothing but VB minus VC, which is equal to epsilon 2 minus IR2. Now, hence the potential difference between terminals A and C of the combination is VAC, which is equal to what we can say here, that is nothing but the potential addition of this and this portion here. So, it will be nothing but VA minus VB plus VB minus VC. Hence, you can find out the value by simple addition, that is equal to epsilon 1 minus IR1 plus epsilon 2 minus IR2, which is equal to epsilon 1 plus epsilon 2 minus I into R1 plus R2. So, this is the same thing which we got here, nothing, just simple mathematical addition. Now, if we wish to replace the combination by a single cell which between A and C of EMF, equivalent resistance epsilon EQ and internal resistance R EQ, then we would have, quite evident, we can find out, let us suppose these are the same AC points here, then we can find out the potential difference between A and C to be equal to epsilon equivalent minus I into R equivalent. So, just putting an analogy in both these equations here, we can find out that the epsilon equivalent epsilon is equal to equivalent epsilon is equal to epsilon 1 plus epsilon 2, and equivalent resistance equal to internal resistance equal to R1 plus R2, and hence this is the complete concept of cells in series. So, comparing the last equation, we get that epsilon EQ is equal to epsilon 1 plus epsilon 2, and similarly R equivalent is equal to R1 plus R2. Hence, this is the complete concept of cells in series. Now, let us move on to the parallel concept here. So, first of all, wait. So, in the above figure we had connected a negative. So, one more concept here. Let us suppose that there are opposite. So, let us suppose in first case we are assuming that the negative electrode is considered with the negative electrode, positive electrode of the another. Let us suppose I change this into this portion here, then what happens? So, it is nothing but in one case it will be positive sign, in another case it will be negative sign. So, then what will happen is, let us suppose there will be a VAB here. So, VAB is nothing but epsilon 1 minus IR1 but VBC, please look here carefully, only the value or the direction of the internal EMF has been changed. Internal resistance will always dissipate energy only, and then it will be equal to minus R2 only. So, it will be minus epsilon 2 minus I into R2. Therefore, epsilon equivalent will be again here epsilon 1 minus epsilon 2, but R equivalent will be equal to R1 plus R2. So, this is the thing which I need to explain here. So, in the above figure we had connected the negative electrode of the first to the positive electrode of the second. If instead we connected two negative equations, we would have the equation would have changed to VBC equal to minus epsilon 2 minus IR2, and we will get epsilon equivalent is equal to epsilon 1 minus epsilon 2. So, this is the final concept here. Let us move on. So, this inequality is also very much required here, because epsilon cannot be negative. So, we just need to understand that the epsilon 2 will be, in such case we just need to reduce the value of epsilon 2 such that epsilon 1 has to be always greater than epsilon 2. Okay. Next, the rule for series combination clearly can be extended to any number of cells, quite evident. The equivalent EMF for a series resistor of n cells is the sum of individual EMF. So, we can just write it in mathematical calculation here. So, epsilon equivalent is equal to epsilon 1 plus epsilon 2 plus dot 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 till epsilon n. Similarly, R equivalent is equal to R1 plus R2 plus dot 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 till Rn. Please make sure here R equivalent is nothing but internal resistance. Okay. So, the equivalent EMF of a series combination of n cells is just the sum of their individual EMFs, and similarly the equivalent internal resistance of a series combination of n cells is just the sum of their internal resistance. Okay. So, this is so when the current leaves each cell from the positive electrode. If in the combination the current leaves any cell from the negative electrode, the EMF of the cell enters the expression for equivalent with the negative sign. So, whereas let us suppose that epsilon 2 was in negative sign, so we will just replace this by minus sign here, that is it. For now I am just writing it as plus here only, but just for your explanation I explained you when the negative sign will be added in the mathematical formulation. Okay. Now, let us suppose we are assuming or we are trying to find out the formulation for cells in parallel. So, now let us take case scenario here. So, consider a parallel combination of the cells in which I1 and I2 are the currents leaving the positive electrodes of the cells. So, here I1 has been leaving here, and similarly I1 after the complete movement in the closed circuit, it will go again I1 and I2 in this portion here also. Okay. At the point B1, so at the point B1 I1 and I2 flow in, whereas the current I flows out. So, since as much charge flows in and out, so because of conservation we can just find out I1 plus I2 is equal to I. I is equal to I1 plus I2. Now, let VB1 and VB2 be the potentials at B1 and B2 respectively. Okay. So, this is another assumption now. Then considering the first cell, it is not an assumption, it is a denotation here. Then considering the first cell, the potential difference across its terminal will be VB1 minus VB2. Hence, we will find out that V of VB1 minus VB2 is nothing but epsilon 1 minus IR1. So, VB1 minus VB2 using the above voltage difference, it will be nothing but epsilon 1 minus IR1. Similarly, from the another point here we will find out that is equal to epsilon 2 minus IR2, I1 R1, I2 R2, because the current which is passing is also different. Let me write it clearly here, it is nothing but epsilon 1 minus I1 R1, and similarly epsilon 2 minus I2 R2. Okay. So, this thing has also been explained, this thing also been explained. Now, let us move on after this. So, combine the last three equations. So, first of all we had I is equal to I1 plus I2. Now, using the equation, so we know that the potential difference V is same across both. So, V is equal to epsilon 1 minus I1 R1, and capital V is also equal to epsilon 2 minus I2 R2. Therefore, from the above equation we can get epsilon 1 I1 is equal to V minus epsilon 1 upon or epsilon 1 minus V upon R1, and I2 is equal to epsilon 2 minus V by R2. Using I1 plus I2 in the equation, what we can get is I is equal to epsilon 1 minus V by R1 plus epsilon 2 minus V by R2. So, now just mathematical formulation, I will try to do the mathematical formulation here. So, here what we can find, that if we need to calculate the value of V here. So, first of all, I is equal to epsilon 1 R2 minus V R2 plus epsilon 2 R1 minus V R1 upon R1 R2. Now, the value is equal to I R1 R2 equal to epsilon 1 R2 plus epsilon 2 R1 minus V into R1 plus R2. Now, more mathematical calculation will give you equal to I R1 R2 minus epsilon 1 R2 minus epsilon 2 R1 equal to minus V into R1 plus R2. Therefore, capital V is equal to 1 by R1 plus R2 multiplied by epsilon 1 R2 plus epsilon 2 R1 minus I R1 R2. Now, just dividing by both, we will get capital V is equal to epsilon 1 R2 plus epsilon 2 R1 upon R1 plus R2 minus I into R1 R2 upon R1 plus R2. This is the final formulation which you obtain for the parallel combination. It is nothing but same as this portion which is written here. As you can see again, so it is nothing but epsilon 1 R2 plus epsilon 2 R1 upon R1 plus R2 minus I into R1 R2 upon R1 plus R2. Now, for the equivalent case, so if you want to replace the combination by a single cell between B1 and B2 of EMF epsilon EQ and internal resistance REQ, we would have V is equal to epsilon EQ minus REQ. So, if we need to take these two equations analogous, we can find the epsilon EQ is equal to, let me change the color. So, epsilon EQ is equal to this portion here, and similarly REQ is equal to this portion here. If you see the R equivalent clearly, it is nothing but the it is same as the parallel resistors which we obtained the equation. So, just to explain you, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 if the resistors are in parallel, and therefore, R equivalent is nothing but R1 R2 upon R1 plus R2. So, this is the same thing which we obtained in the previous discussion of cells in series and resistors in series and parallel also. Hence, so finally, we can obtain the equation is nothing but epsilon EQ is equal to epsilon R2 epsilon 1 R2 upon epsilon 2 R1 upon R1 plus R2, and R equivalent is nothing but R1 R2 upon R1 plus R2. So, now just making it mathematically more easier, we can use this equation in simpler way. So, first is the mathematical formulation for parallel only, that is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Similarly, for equivalent resistance, equivalent cells, we can say that the equation is epsilon EQ upon REQ is equal to epsilon 1 R upon R1 plus epsilon 2 upon R2. So, you just need to remember this concept here. So, finally, I think this is the end of the cells in series and parallel only. There will be a simple denotation of positive and negative electrode here, but just to conclude this, I just need to explain it again. So, first of all, for series and parallel, it is nothing but there will be an addition of for the series, it is simple, epsilon EQ is equal to epsilon 1 plus epsilon 2 plus dot 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 till epsilon n, and similarly REQ is nothing but R1 plus R2 plus dot 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 till Rn. But for parallel, it is nothing but R1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus dot 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 till 1 by Rn, and similarly for epsilon q it is nothing but epsilon eq upon r eq is equal to epsilon 1 upon r1 plus epsilon 2 upon r2 plus dot 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 till epsilon n upon rn. So, this is the final conclusion, this is the final formulation for the cells in series and parallel. Let us move on with the further discussions. So, here in the above equation we had joined the positive terminals together and similarly the two negative ones, so that the currents I1 I2 flow out of the positive terminals. But what will happen if the negative terminal of the second is connected to the positive terminal of the first? Equation would still be valid, but only we just need to change the value of epsilon 2 to minus epsilon 2, that is it, everything will be same, only we just need to reverse the direction of epsilon 2. For first, let us suppose it is plus 5 volts, we will change it to minus 5 volts. Let us suppose if you are taking an example, if the epsilon 2 is giving you a 5 volt supply. Okay. So, this thing is also been explained, this thing is also been explained. Now, above equivalent equation can be extended easily. So, equivalent extension has been done for n series or n parallel cells. So, if there are n cells of EMF epsilon 1 till epsilon n and of internal resistance R1 to Rn respectively connected in parallel, the combination is equivalent to a single cell of EMF epsilon Eq and internal resistance Req, such that 1 by R equivalent is equal to 1 by R1 plus 1 by R2 till dot 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 till 1 by Rn. And similarly, epsilon Eq upon Req is equal to epsilon 1 upon R1 plus epsilon 2 upon R2 plus dot 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 till epsilon n upon Rn. So, this is the final formulation for cells in parallel, and similarly that was the final formulation for cells in series. So, that is the end of this discussion also. Let us move on with the new discussion of Kirchhoff's rules. So, what is Kirchhoff's rules? Kirchhoff's rules are basically implemented because there is a complexity of many resistors taking place. There will not be a simple diagram given to you as these two are resistors, try to find out the equivalent resistance. In real life scenario, there are many bunch of haphazard resistors being kept intact with different forms, and therefore, these rules have to be come into pictures. Okay. So, electrical circuit generally consists of a number of resistors and cells interconnected, sometimes in a complicated way. The formula we have derived earlier for series and parallel combination of resistors are not always sufficient to determine all the currents and potential differences in the circuit. Two rules called as Kirchhoff's rules are very useful for the analysis of electrical circuits. Given a circuit, we start by labeling currents in each resistor by a symbol say I and a directed arrow to indicate that the current I flows along the resistor in the direction indicated. This line I will try to explain, I will try to explain the Kirchhoff's rule using an example. If ultimately I is determined to be positive, the actual current in the resistor I is in the direction of the arrow. If it is negative, then we just need to remove the direction, and that is the complete sense of Kirchhoff's rules. If I turns out to be negative, the current actually flows in a direction opposite to the arrow. Quite evident, this thing has also been explained. Similarly, for each source, that is cell or some other source of electrical power, to the positive and negative electrodes are labelled as well as directed arrow with a symbol for the current flowing through the cell. This will tell us the potential difference V, which is equal to epsilon minus IR. So, you just need to explain that if let us suppose we are taking a case into scenario, if this is the, if this I am taking a very simple case of this to be a resistor, this to be an ideal battery which is having a resistor R, it is having epsilon. So, if we start from this point here and we move in this direction, then it is nothing but due to this there will be a reduction which is equal to minus IR, and due to this there will be an addition which is equal to plus epsilon. Hence, this is nothing but the complete one of the example of Kirchhoff's rule. So, just it is nothing but epsilon minus IR. I will try to explain it more deeply using one of the example, 2-3 examples which I added in the slides, in the subsequent slides. For now, let me stop it here only. In the next lecture, I will start with the two rules which are known as Kirchhoff's rules. So, let me stop it here. So, the course progress for you. Introduction thing is done, electric current is done, mathematical formulation was being explained in this, electric current in conductors is done, Ohm's law, that is V is equal to IR is done, drift of electron concept, VD concept is also done, limitations of Ohm law has also been explained to you, resistivity of various materials has also been explained, color coding has also been explained nicely to you using 3 examples. Temperature dependence of resistivity has also been explained, that is how the temperature dependence of resistivity based on conductors, semiconductors and insulators are being put into good use. Then electrical energy in power in which the product of V and I is equal to I square R is equal to V square by R has also been explained to you. Then combination of resistors in series and parallel. So in series nothing but the addition, simple addition, R1 plus R2 plus R3 dot dot till Rn, and similarly in parallel it is nothing but 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 dot dot till 1 by Rn. Similarly, cells, EMF and internal resistance has also been explained in the previous concept only, and finally we have ended up with cells in series and parallel also. So cells in series nothing but epsilon equivalent is equal to epsilon 1 plus epsilon 2 plus dot 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 till epsilon n, and R equivalent is equal to R1 plus R2 plus R3 plus dot 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 till Rn for cells in series. Similarly, for cells in parallel, epsilon first of all we need to calculate the value of internal resistance. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 dot 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 till 1 by Rn, and similarly epsilon equivalent upon R equivalent is equal to epsilon 1 by R1 plus epsilon R2 by R2 dot dot till epsilon by Rn. In the next lecture, I will start with the complete discussion of Kirchhoff's rules, and finally there will be 3 applications of Kirchhoff's rule, that will be the Wheatstone bridge, meter bridge and potentiometer, and that will be the complete end of your current electricity concept. So let me stop it here only. Thank you.